Hello again, friends. In this video we're going to try to find the volume of a shape created when we rotate a region around the x-axis, and in this video we're going to be trying to use the washer method. So as we can see, we're going to be working with these two functions right here. We're going to be working with y equals 5x minus x squared and y equals x, from x equals 0 to x equals 4. So you can see that that's this shape right here. And this is our parabola, and then this is y equals x. So the first thing we know that we're going to be doing is we're going to be rotating this guy around the x-axis. So if we do that, and we rotate him around here, we're going to see that here is our line y equals x. And then this is what our parabola is going to look like over here. So we're going to have a shape that looks something kind of like this, right? And if we were to draw this out, we'd see we have kind of like this bowl shape, right? And then kind of and this is our axis, right? And then we'd see that on the inside what we'd have is this cone in here that is empty, right? Because the only place that has volume are the places in between these two regions. So everything in the cone is just like an empty bowl. So now that we kind of have a visual of this, we have to figure out, all right, how are we going to find our volume? So what we did before, in like the past couple of videos, is when we were using the disk method, right? We'd pick a rectangle and say it had a volume or a width of dx, right? And because we're using the disk method, what we did it from the axis of rotation up to the function. But here we have two functions, right? So it makes things a little bit different because we don't want to include this area down here, right? So what we have to do, since we're only working with the area within these two curves, we have to take the length of the rectangle to the function here and subtract out the length of the rectangle to the function y equals x. So we have this whole rectangle up to the function y equals 5x minus x squared. Now we have to subtract out the length of this rectangle right here up to y equals x to get just the rectangle with length dx, not length, with dx, that has a length between these two curves. Now we see that what happens when we rotate this rectangle all the way around, what we're going to see is that we're going to have a kind of a washer shape, right? Because this is going to rotate all the way around our curve here. This rectangle is going to kind of be like a donut or like a washer all the way around. So, but what's in the middle around the cone, that is going to be empty. So it's just going to be, like I said, that donut shape around our cone. And we can kind of see that using our disk method before, what we did is we had a radius of, we see that, yeah, it's a circle, right? So it had a radius from the axis up to the function, right? And then that kind of explained how our formula worked out, right? Because we have pi r squared times before, for disk, we had from a to b, we had pi r squared dx, where our radius was the distance from our axis to our function. So from our axis to our function, right, because this whole thing makes a circle. Once we rotate it around our axis, we now need to figure out the area of our circle, multiply it by the width of the disk, the circle, and that's how we got our, when we integrate that, we got our volume. Well, here we're doing something similar, except like I said, we have to subtract out part of our length of our rectangle, part of our radius, And when we do that, we're subtracting out another disk, right? Because in here is kind of its own disk, right? You can kind of see that if we were to rotate this all the way around, it'd have its own disk in there. We need to subtract that disk out. So this disk and the inside of our cone has a radius from the x-axis to the function y equals x. So that's this radius. So we have to subtract that radius out, that disk out with that radius from the disk from the x-axis all the way up to the function y equals 5x minus x squared. Once we do that, all we're left with is this orange disk right here, or orange washer that we want. So, doing that, let's set up our integral. So, like I said, we know what we're integrating it with respect to. We're integrating from 0 to 4 in terms of x. Now we have our disk equation, right? Pi r squared, because this is the area of a circle, right? These are circles that we're creating when we rotate these rectangles around our axis. So pi, and our radius from the top is the larger radius, right? So that's from our x-axis to our function at the top, because our function defines our radius, right? Because our radius from here to here is different from our radius from here to here, because our function tells us when to stop. So we can plug in our function for our radius. That's 5x minus x squared. Now we're going to subtract out. So that told us the whole disk from the x-axis here. Now we have to subtract out this tinier pink disk on the inside to get this nice cone inside of our bowl. So you're going to subtract out pi times our radius, which that's our radius from our x-axis to our to the bottom radius, right? So the bottom function. So that's y equals x. So we're just going to plug in an x squared dx. Now we can integrate, and then we can get our volume once we're done with that. So let's get started with that. So I'm going to erase this picture right here. So once again, this is kind of like two disk equations, right? We have the bigger disk, we're subtracting out our smaller disk, and then we're multiplying it by the width of our disks. So now that we have that set up, we can FOIL things out nice and beautifully. So we're going to have 0 to 4, and I'm going to pull my pi out since we have a pi in both of them, just because it's going to hang out the whole entire time. So we're going to have, now we have 25 x squared minus 10x cubed plus x to the 4th. And then this is just going to be minus x squared dx. Right? So now what we're going to have is we're going to combine our like terms. So we're going to get pi, 0 to 4 still. And then this is going to be 24x squared. So these two guys are going to subtract out. That's a squared. And then we're going to have our minus 10x cubed plus x to the 4th dx. Alrighty. Now that we have it nice and simplified, we can integrate. So we have x squared. We're going to add 1 to our exponent to get x cubed. We're going to get 24 over 3. Now we're going to add 1 to the exponent here. So we're going to get x to the 4th, divide by or multiply by our reciprocal. So we're going to get 10 over 4, x to the 4th, and that's negative. And then last but not least, we're going to add 1 to our exponent here. So we get the 5th, multiply by our reciprocal, and then our sign stays the same. So we're going to get a plus right here. Finally, we have to evaluate between our bounds from 0 to 4. So we're going to plug in 4. So we're going to have 24 over 3 times 4 cubed minus 10 over 4 times 4 to the 4th plus, oops, that's supposed to be 1/5 times 4 to the 5th, and then 0, when we plug in 0, we're just going to get all zeros. So really all we have left is to figure out what this is going to be. And when we plug all of this into our calculator or work our math out, we're going to see. And then, like I said, I forgot, we're multiplying by pi all the way through, right? So this is all times pi. Pi, he just kind of hangs out and follows us all the way through. So our final answer is going to be 384 over 5 pi. And that is our volume of that figure that I drew before when we rotate this region right here around our x-axis.